Okay, this is a video for 2-61 through 2-66. So if you don't need certain problems, just fast forward till you see me working out the problem that you need. I'm looking at 261 and it says to enlarge the shape at right from the origin by a scale factor of 4. So that means this is going to be 4 times as big. So I'm thinking about that as I'm situating it on the paper, and I'm noticing that the distance from the origin to this point is 3. So if I'm multiplying that by 4, I'm going to need to have a graph that goes all the way up to 12 on the y-axis. So think about that as you're putting your x and y axis on your paper. Okay, so we've got this shape for the original, and it has 4 sides, so that means it's a quadrilateral. Oh, that doesn't look right. There we go. Okay, so we're dilating by a factor of 4. So I'm just going to see what the coordinates at this point is and multiply by 4. So 2 0 is going to become 8 0. This is 0 3. So that's going to become 0 12. And this is negative 2 0, so that's going to become negative 8 0. And this point here is 0 1, so that's going to become 0 4. Okay, for 262, it says the ratios that Casey wrote from part A of problem 258 are ratios of the lengths of corresponding sides of the 2 shapes. So they're referring to that problem we did with the C shape. And remember, she wrote 24 over 8, 18 over 6, and then her brother writes 8 over 6, 24 over 8. So she was comparing the heights and the widths, and then he just decided to compare height to width, height to width. So I'm going to draw these 2 triangles for 262. I don't need graph paper. Okay, so I've got, and yes, you are expected to draw the triangles. Okay, part A. Look at the similar triangles below. Which sides correspond? Write ratios for corresponding side lengths. So the sides that correspond are going to be the ones that would overlap. If I were to map this triangle on top of this triangle. It doesn't say which one's the original, but if I were to go from here to here, that would definitely be a rotation and then a translation. I'd have to rotate it and then move it to the right and probably up. So the sides that would overlap would be 15 and 6. So I'm going to put 15 over 6, and then 20 would overlap with 8. And if they're similar, they should reduce to the same amount. So 15 over 6, 15 divided by 15 divided by 3 is 5. 6 divided by 3 is 2. So that reduces to 5 over 2. And 20 and 8 are divisible by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. So that also reduces to 5 over 2. Okay, part B. Calculate the length of the hypotenuse of each triangle. So I've noticed that a lot of people are skipping this in homework. I don't know if it's just that you don't know how to do it, or you just don't feel like doing it. But let's make sure everybody gets up to speed with this, because you need this skill as we move along. Is the ratio of the hypotenuses equal to the ratios you found in part A? So I'm going to start with a squared plus b squared equals c squared. I have two legs that are 15 and 20. So the legs go in the place of a and b. C is always my hypotenuse. Now I'm working through this quickly. If you need to slow the video down, pause it so that you can see what I'm doing in each step. Do that, and eventually you'll get faster at it as you practice with it. The opposite of squaring is taking the square root, and the square root of 625 is 25. So the hypotenuse of this triangle is 25. Okay, now let's do Pythagorean theorem with 6 and 8. So that's going to give me 6 squared plus 8 squared equals c squared. Square root of 100 is 10. Whoops. So the hypotenuse is 10. So now I'm going to look at the ratio of the hypotenuses. Now I had started with this triangle on top, so I need to stick with that. If I do 15 over 6, then I have to do 20 over 8. And the next one I'm going to check is 25 over 10. Both of those are divisible by 5. And it does reduce to 5 over 2. Okay, C says describe a series of transformations that would map one triangle onto the other. So I, again, don't have tracing paper at home. If I were to just use a sheet of paper and trace this triangle, I'm going to do a little XY axis right next to it. I would definitely need to rotate it, and I kind of can see through the paper, through the graph paper, and see that it's lining up. I would also need to translate it to the right and then translate it down. So I would say rotation and translation. And then this is a smaller version of this one, so I would also add dilation. Okay, 263. Match each description below with the most appropriate graph and briefly explain why it matches the data. So, part A, the price of a pair of jeans at a department store during a given time period. Well, I'm thinking the price of the jeans is going to go down, because usually when something's new, that's when it's cost the most. So I'm thinking it's going to match graph 2. I'm going to check out B and C before I make a decision. Part B, temperature of water being heated in a pot on the stove. Well, I know that when I heat up the water on the stove, it gets hot and then it reaches the boiling point. Okay, so I know that's going to be going up, and then it's probably going to hit that boiling point and then stay at that temperature. Part C, river miles traveled during a rafting trip. Okay, well, if you're on a rafting trip down a river, you're going to travel for a little while, then you're going to stop, and then you're going to travel for a little while and stop. So the miles that you travel is going to increase, and then it's going to look like it's staying the same. Increase, look like it's staying the same. So it looks like part A would match graph 2. The jeans start out at a high price, and then they keep them on the rack at that price for a while, and then they say, hey, let's give them a discount, let's bring these down, keep it at a discount for a while, and so on and so on. Eventually they're almost half the price of what they started at. So graph 2 for part A. Part B, if you're heating up water in the stove, it's not going to heat and then level off. Heat, level off. It's going to heat up, and then it reaches the temperature that it's boiling, and then it stays at that temperature for boiling. So this must be, B must match with graph 3, and then the river miles traveled during the rafting trip must be graph 1. You're traveling a certain amount of miles, you stop, you take a break, so you're staying at that amount of miles, and then you keep going, and then you take a break, you keep going, take a break, and so on. Okay, so that's 263, 264. Okay, we did not all quite get to the lesson that goes with this problem, so I hope you are going to get something from this if I show you a video on it. Let me show you on the paper. Okay, so if we have, and there's an e-tool that goes with this, but I don't think I can flip to it at this point. I have to use a different little recorder if I record from the computer screen. But I think we can visualize it just with me drawing it. If I have two sides of a triangle, one is 3 and one is 5. Okay, I'm going to put those next to each other. Okay, obviously this is not to scale, I'm just sketching it. If this is 3 and this is 5, if I have another side that's 8 units long, it's going to lie flat on top of that. And that would not make a triangle because you need to have 3 points that are not all on the same line. If I had a line that was 7.9 units long, then it would make a very, very, very tiny triangle or small height. So basically anything less than what these two together would be would work. If I had something like 2, okay, so let's try to see what that would look like. If I had a side length of 2, okay, so one side is 2, one side is 3, and one side is 5. Here's the side that's 2. Here's the side that's 3. If the third side is 5, that's just going to be flat on top of this. That's just going to overlap this. It would have to be a little bit more than 5 so that I could actually have a triangle here. So it couldn't be 2, but it could be 2.1. So basically the answers would be somewhere between 2 and 8. It can't be 2, it can't be 8, but it could be between 2 and 8, so I'm going to write it like this. It could be less than 8, it could be greater than 2, or you could just write it in words. X is between 2 and 8. So the shortcut for that is if you were to subtract these two, that would give you the lower limit. If you were to add them, that would give you the upper limit. But it's good to have a visual on this, and there's actually a really good e-tool that kind of lets you rotate these around to see the actual length. And that is called triangle inequality. Okay. For 264 part B, we have a right triangle. One side is 5, one side is 12, and one side is 14. Well, if this is a right triangle, then those sides should, the sum of the square of these two sides, if I square 5, that gives me 25. If I square 12, kind of ran out of room, that would give me 144. That should be equal to whatever this hypotenuse squared is. So let's check that out and see if it works. 5 squared plus 12 squared. Let's see, does that equal 14 squared? 5 squared is 25. And 12 squared is 144. But 14 squared is 196. So if I add 25 and 144, that gives me 169, which is not equal to 196. So this is impossible. That would not be a right triangle. You can't have these two not be equal. The square of the sum of the squares of your two legs has to be equal to the square of your hypotenuse. So impossible. Okay, part C. All right, we have an angle of 55, an angle is 65, and a side here that's 7, and a side here that's 7. Oh, well, if these two sides are equal, that's an isosceles triangle. Base angles in an isosceles triangle are congruent. These are called the legs of the isosceles triangle. This is called the base. And I didn't draw that quite like an isosceles triangle. Be more like this. Okay. So these two angles are called the base angles, and if this is an isosceles triangle, they have to be equal. But now I see I have an angle of 65, 65, and 55. 65 plus 65, that's 130, plus 55, that's 185. And all the angles in a triangle should add up to 180. So this is not possible. C is impossible. Okay, 265. I hope you're getting the hang of these diamond problems. This is going to come in very handy when we get to factoring quadratics. Draw the diamond. You will be drawing diamonds when we get to that unit. And it always gives you a little hint on how to do these. This number up here is the product of x and y, and this number down here is the sum of x and y. Okay, so I've got, let's see, 7 and negative 98. So I know something times 7 equals negative 98. So I'm going to figure out what that is by dividing. I'm just going to do negative 98 divided by 7, and that would give me 14, negative 14. And then I'm going to add 7 and negative 14, and that would give me negative 7. Okay. Okay, now I know you may not love fractions, but these are not too difficult to work with. I'm just going to add or multiply 3 over 2 times 3 over 2. When I multiply fractions, I multiply numerator times the numerator, denominator times the denominator. So that gives me 9 over 4 for the product. And then when I add them, they have the same denominator, so I can just go ahead and add the numerators. That's going to be 6 over 2, and 6 divided by 2 is 3. All right, part C. Okay, so I know something times negative 5 over 2 is going to give me 5 over 4. So there's a lot of ways you could approach this. You could say x times negative 5 over 2 equals 5 over 4, and then go backwards to solve for x. I think I'll do that this way. If I'm going backwards, if I want to divide by negative 5 over 2, this is multiplication. The opposite of multiplication is division. If I want to divide by negative 5 over 2, that's the same as multiplying by negative 2 over 5 by the reciprocal. Negative 2 over 5 times negative 5 over 2 is going to give me positive 1. So these are going to cancel out. And if I multiply by negative 2 over 5 on the left, I have to multiply by negative 2 over 5 on the right. So I know the answer must be, when I'm multiplying fractions, I multiply numerator times numerator, denominator times denominator. 5 times 2 is 10, 4 times 5 is 20. Positive times a negative is a negative. That reduces to negative 1/2. So this must be negative 1/2. Now, if you want to do that a different way, that's fine. You may be able to just do that looking at the one factor and figuring this out. Okay, and then I'm going to negative 1/2 and negative 5 over 2, negative 1/2, and negative 5 over 2, same denominator, so I can just add the numerators. It's going to give me negative 6 over 2, which would reduce to 6 divided by 2 is 3, and that's going to be a negative 3. And I know I'm going quickly, just slow the video down, pause it if you need to write things down or kind of process what I'm talking about. Part D. Okay, I know something times negative 10 is going to give me what goes here. And I know something plus negative 10. Remember, the top part is x times y. The product at the bottom is the sum. So I know negative 10 plus something is going to give me 0. Now, if you don't know what that is, you could just make a little equation. Negative 10 plus something is 0. To get y by itself, add 10 to both sides, so y equals 10. And then I'm going to multiply negative 10 times 10 to get the top part. So negative 10 times 10 is negative 100. Okay, 266, we have Renee's MP3 player can be programmed to randomly play songs from her playlist without repeating a single song. Currently, Renee's MP3 player has 5 songs loaded on it, which are listed at right. At the moment, she only has time to listen to one song. Is each song equally likely to be chosen as the first song? Well, if you've got 5 songs and it's randomly playing the songs, then there's an equal chance for any of these songs to be played. So yes, there's an equal chance for any of these songs to be played first for part A. Part B, the probability that her MP3 player will play a country song. Okay, well, we've got 2 country songs out of 5 country songs, so 2 out of 5 for part B. Part C, the probability that she's going to listen to a song with Mama in the title. I see 3 songs with Mama in the title, so 3 out of 5 for part C. Part D, the probability that she listens to a duet with Hank Tumbleweed. Okay, well, I only see one song that's a duet with Hank Tumbleweed. So 1 out of 5 for part D. And then part E, what's the probability that she listens to a song that is not R&B? Well, I only see one R&B song, so there's 4 out of 5 chance that she's going to listen to a song that's not R&B. Okay, I hope this helped, and I hope you get your homework in.